Okay, suppose you want to derive the following formula. Phi and psi implies psi and phi. So what's going on here that we just switch the order of phi. So first we have psi, and then we have phi, and here we have first phi and then psi. So this is known as commutativity. Switching the order, the result doesn't change. So how can we go about deriving such a formula? It's always important to realize in these cases that we have an implication. So we have an antecedent here, and then we have a consequent. And in such cases, you always want to assume the antecedent. So assume the antecedent, in this case is phi and psi, and then try to arrive at the consequent. And in this case is phi and psi. Assume the antecedent, try to arrive at the consequent. So let's do that. So let's assume the antecedent. Okay, so we're assuming the antecedent. We put it between square brackets, phi and psi, and we call it number 1. Okay, so we need to arrive at the consequent. So I'm going to put the consequent somewhat down here. So phi, psi, and phi, that's our consequent we need to arrive at. How can we get from this assumption here to the consequent here? Now, one technique that we might have is to work backwards. We know what our starting point here is. We know what our goal is, but what's happening here in between? We need to fill the gaps. So if we work backwards, we can maybe try to get back here. So how can we get to phi and psi? This is a conjunction. So in order to get to a conjunction, you probably have applied the rule of conjunction introduction, where you had derived phi, psi on the one hand, and then you have derived psi on the other hand. So these are going to be separate derivations. And then we put them together and we get phi and psi through the rule of conjunction introduction. Now, how can you get from this assumption here to our psi here? That seems pretty easy, because if you realize that we have phi and psi, this is our assumption number 1, so I'm just repeating the assumption here. From this, by conjunction elimination, we can get psi. We just pick one of the two conjunct, in this case the second one. We can repeat the same thing on this side. We assume the same thing, phi and psi, so we call this assumption number 1. But in this case, instead of picking psi, we pick phi, the first conjunct. So we again use conjunction elimination. So I'm just kind of, like, this one is not playing any role. And so we have this assumption here. It's the same assumption, so we call it number 1 because it's the same. In one case, we get phi out of it. In the other case, we get psi out of it. But in both cases, we apply the rule of conjunction elimination. And then we put the two together. Now notice that the trick here has been that on the left-hand side, we pick psi. And on the right-hand side, we pick phi, which allows us to invert the order of psi, of phi and psi. And so we get the reverse order here. Now we're almost done. Now we need to get the implication here. And so what we need to do is to apply the rule of implication introduction that is indexed to assumption number 1 here. And so we can write phi and psi implies phi and psi. So we just switch the order. So we use conjunction introduction, we can eliminate our assumption, and our derivation is done. Now, it's important to keep in mind always, so keep in mind the rule of implication introduction. The rule has the following shape. You assume a formula A, and then you get to a formula B, and then you can write A implies B, and then you can cancel your assumption. And it's always important to index your assumption to some number. So I'm calling it I is some number. Can be 1, 2, 3, or whatever you want. And so what the implication introduction done is that it turns a relationship between A and B that is vertical into an horizontal relation. So it puts your A as the antecedent here and your B as a consequent here. And so if we go back to our derivation here, this is precisely what we've done. We had our assumption here, phi and psi, and that has become our antecedent. And then what we got here at the end has become our consequent. That's what the rule of implication introduction does. So once we've done that and realized that, we're done.